So following on from some of the earlier videos, our aim here is to prove these identities here. And the way we do that is to set up a scenario where we have a circle of radius 1. So this here has a radius of 1. And because we know that this length here is the same as this length here, then by using Pythagoras in one of the earlier videos, by using Pythagoras, we managed to work out P. We managed to work out P. So P here is this P here, and then R here is this R here. So basically, this length here, we managed to work out PR squared, which is this bit here, equals this. And this was done in one of the earlier videos. And we also worked out QS squared. So this distance here is QS here. Well, by using Pythagoras, QS squared equals this here. Okay, and both of these were done in some of the earlier videos. Okay, so we've covered these two here. Now in this video we're gonna well because this distance here, because this distance here is exactly the same as this distance here, we can actually write, we can actually say PR squared equals QS squared. Okay, so yeah, because if this here is 7, let's say this is 7 centimeters, and this is also, let's just say 7 centimeters, then we can actually write 7 squared equals 7 squared. Well, you can do that. Okay, so so now PR squared equals QS squared. So now it's just a matter of well, this is your PR squared here. So PR squared is this bit here. Okay, and QS squared is this bit here. So we can now say this is PR squared equals QS squared. Okay, so now it's just a matter of tidying up this equation here. So take away 2 from each side. Okay, so take away 2 from each side, so you're just going to be left with this. That's this bit here, and when you take away 2, this here goes, leaving you the rest. Here. Okay, so so from here we take away 2 from both sides. That will give us this here. Okay, and then now divide both sides by -2. So when you divide both sides by -2, divide by -2, so these two will kill off each other here, leaving you this. And when you divide by -2 here, and then divide by -2 here, these two here will kill off each other, leaving you this. And then this here, well, we're going to merge these two. That will give you -1. So that's why you got this minus and the 1 here. But we don't bother writing the 1. Okay, so basically divide both sides by -2. So from here, that will take us to here. And remember, our aim was to find these out. And well, when you get to this stage here, this is exactly the same as this one here. So this one is done. We've just proved that when if you have cos alpha plus beta equals this, and look at this up here is the same thing. Cos alpha plus beta equals this, exactly the same as this here. Okay, so that's this one done. Okay, so looking at this here, this is exactly the same as, is exactly the same as this. I've just copied and pasted it down here. Okay, so from above, that's what we've got to here. Okay, so now we our aim is to prove these 4, but we've only done 1. But to do this one here, it's quite easy to do this one here. Once you've done this one, it's quite easy to do this one here. Okay, so now we've done this. Our aim now is to do this one here. Okay, so looking at this one here, that's me copying and pasting it down to here. But now visualize this, visualize it as this. Now visualize it as so here you've got cos alpha plus, let's just say bubble here, and then equals cos alpha times cos, and then just imagine the beta as being a bubble. Okay, so we can visualize it like this. So alpha plus, so cos alpha plus whatever in here, and then whatever in here, and whatever in here. But the thing is, you can actually well, here you've got a formula for one angle. It doesn't matter what angle, plus another angle. It doesn't matter what angle over here either. So we can put anything inside this bubble here. We can actually put minus beta into here, and then put minus beta into here. Put minus b, because minus beta is an angle. So here you've got a formula for any angle plus another any angle. Well, we can minus beta could be another angle. So visualize it like this. Now now we can take the minus out here. Take the minus out and put it out here. Okay, so now your formula then becomes this. So earlier was this. Earlier was minus beta inside the bubble here. So now take away the minus from within the bubble and put it on the outside here. So it becomes this. Okay, now this is positive. So so now the same with this thing here. When you look at this here, remember that. Hang on. Remember that. Hang on. Let me put minus beta in here, minus beta in here, and minus beta in here. So this bit here then becomes this. And remember, looking at this here, remember that cos the cos graph, cosine graph looks like this. It's an even graph. It's an even function here. So minus beta, because anything that's even, because it's an even function, because it's an even function, cos minus beta is the same as cos beta, because it's an even function. Okay, so this thing here, we know this is exactly the same as this. Whenever you have an even function, just like y, just like f of x equals x squared, is an even function. So you doing minus minus 3 squared, that's the same as you doing 3 squared. So why not? Well, just ignore this and just do the positive version. It's easier. So just ignore this negative version and do the positive version, because it's an even function. Now looking at this sine minus beta. Now sine is an odd function, so it's like this. It's like this. So because it's an odd function, because it's an odd function, minus sine. Because it's an odd function, sine minus beta, that's the same as minus sine beta. So because it's an odd function, because it's an odd function, sine minus beta is the same as minus, and just do the positive version of that. So you can think of it like this. Because it's any odd function will always, well, rather than doing the negative version, you can just do the positive version and then stick a minus in front of it. And just because it's an odd function, you can do that. Okay, so hang on, minus beta in here, minus beta in here, minus beta in here. So this bit here, because an even function here, you can just forget about the negative, and here is an odd function. So if you have an odd function, hang on, that then becomes minus sine the positive version. So visualize this as a minus 1 here times this bit here. So now get the minus 1 and move it outside here. Okay, so that would then become, so minus 1 here times a minus here. So move it out here. So that will give you a positive. Okay, so now we've done the other one. So here, so our aim was this right from the start. Hang on, let me just move this across. So our aim here, this was our aim. We've done this one from above, and then now when we get to this stage here, you see this here is exactly the same as this. So therefore, we've done these two now. So these, we've still got two more to go. Okay. So I will continue in the next video. Okay.